Okay, so welcome. It's Sunday, and we have a group of students here that ICAS is teaching how to use Dynair Julia, and so we're working today on this model called EndoCred, which is a paper. The model's going to be documented in this paper for Oxford Economic and Policy. And then tomorrow, we're going to be live streaming showing how you can use various types of AI to draft working papers, in this case, a chapter of a book tomorrow. But tomorrow, we're also going to look at using Diner Julia to solve the global integrated monetary fiscal model. So we have a project with Sunhwa Yi at the World Bank to investigate the implication of aging on, in this case, Thailand and Laos, and how artificial intelligence potentially could raise productivity in certain sectors, such as the elderly care sector, but other sectors of the economy as well, and how that might help dealing with a potential aging crisis that is coming. Uh, so on that note, I think I'll turn it over to HiCast, and hopefully today we'll be able to run scenarios in EndoCred. So please, HiCast, we're excited to learn again today from you.
And thanks, Doug. So I will continue from the point we finished yesterday. Let me share my screen and go through the code. Yeah. Okay. So we yesterday we starting by going looking at the Oxford paper and the results, and the idea of this course is to equip you with the modeling system, so you can replicate the results of the Oxford paper using two-country EndoCred. We talk about the specification of the model, and we starting looking at some properties of the Dynar, macro processing, and how to write down the equations properly, and we're starting going step by step through the code, and I guess we stopped here, looking at the output gap equations, and again here we use this Dynar notation. But then let's move on. So because this model is two-country model, and there is some flow of financial resources between countries. We have this UIP condition. There is a capital flow, and there are a bunch of which is of course the behavioral or the main equation, and there are some definitions here which we are using, like definition of the real exchange rate, and some changes in the exchange rate. Then we are using the information from yield curve to enrich our analysis, and here particularly in this specification of the model we have 6-month term premia, 1 year to up to 10 years. When we are looking at the US, and as you can see, these equations are just simple processes. They have some persistence, some persistence there, and go to some long run, we can call long run steady state, which are these term 6ms and other, and this is pretty standard in QPM type of models. And when we're looking at the historical developments of the US economy, so we can think that then 10-year term premium is around 1%. So we took this value as a calibration for 10 years, and for 5 years it's half of that, like 0.5. We can search this and see that, for example, 10-year term premium instead steady long run, it's 1. So it doesn't depend in what point we are starting. In some periods it below 1, in some periods it's higher than 1, but in the long run it's going to 1%. Similarly we did for other periods. And then this familiar thing where we are constructing the long run interest rates using macro processing. We talked about this, so I will skip. Then we kind of construct the long run interest rate out of as a sum of the expected path of the short run interest rates plus the term premium. So which is called like the expectation hypothesis of the interest rate or expectation theory. Then here we do bunch of we added bunch of interest rates, like 1 year expected real interest rate, so or on 3 years expected real interest rate. So we are doing all this step just to build the so-called long run interest rate, or you can call it effective interest rate, which we think that affects the aggregate demand conditions in the economy well. So not only the short-run interest rate effects, but also the entire path of the short-run interest rate. And we just write down all this equation. I guess Ani also showed in her presentation how we build the long-run interest rate. And the idea of having the long-run interest rate here is that it's gap affecting aggregate demand conditions. And again, here we built it in a user-friendly manner, so you can here choose just operate in choose do you want that long-run real interest rate affects the aggregate demand condition or short-run? Again, by changing the value introduction, the long-term prem to other values than 0, we switch to the standard representation of the demand equation. So all these things are good, and then we have some time varying inflation target. So these things are not so are not behavioral things. So then we can just have a high level view and skip these parts. Again, there are some persistencies of the shocks, which are represented by simple autoregressive processes, and then here again, the new notation in DINAR, when we are looking at the reaction function of the ECB, we are using, we write it in a way to have the ZLB constraint. So in the simple rules, we don't have, of course, which is this part. when the interest rate has some persistence in it, then it reacts to deviation of the expected inflation and the output gap, right? But in this specification, when you are using, because in our experiment which we are going to do, we are looking at the COVID period when the interest rate are stuck at the ZLB, and we can't get the ZLB by writing the standard reaction function. It will go below zero interest rate. Because the conditions of the economy are so deflationary, so nominal interest rate should go below zero. That's why here in Dynar, using this command, max parentheses, you write down the standard reaction function or the reaction function you want, comma, zero. What it says that the maximum of this part, the first part, the value of the interest rate as maximum between choose, for example, setting the value of the interest rate is zero or some value which you can get by reaction function. For example, a reaction function requires that the interest rate should be 4, right? And then by this command max 4 and 0, it will choose 4. But when standard reaction function requires that the interest rate under these economic conditions should be, for example, -5, Dynar chooses maximum between -5 and 0, which is 0. So this is the way to write down the reaction function with ZLB constraint. Then I closed the reaction function of the Fed. Instead, we are saying that US Fed is using the loss function to operate the monetary policy, but ECB is using much less complicated framework. And the next are just I guess they are definitions. You can then, if you are interested, go through it, but these are not so important. Then we enter the model block. As you see, we closed here the Fed monetary policy reaction. Now we have, for example, one equation less than endogenous variables. Let's say we have 100 endogenous variables, but 99 equations. And then next, the final equation will be loss function, which will write a bit down the other blocks. But the next block after finishing the model, so we start with model and semicolon. Then, because our model is non-linear, or even if it's a linear, if we write down the model in levels, which means that the steady state of the variables are not represented as a deviation from their steady state, which means that in that case, in steady state, the deviation of variables from their steady state should be zero. So we will not need to have the steady state model block because all the values of variables is zero. But here we need to define the steady state model. Okay, and for these kind of models, it's very simple to write down the steady state block of the model. In other models, let's say GINF, which is a structural model, and there are hundreds of behavioral equation. It's not so simple to find out analytically the steady state of the model. In that kind of frameworks, we are using the numerical methods to calculate the steady state, starting from some guess values. But in QPM type of models in Endocred, the calculation of steady state is super simple. What we need to write down in steady state model, we need to write down all these endogenous variables of the model, which we defined at the beginning of the mode file, denoted by var, all the endogenous variables of the model, as a define the values of all these variables in steady state. So it's very simple. Let's say inflation in steady state should be equal to inflation target. It's obvious, right? In steady state, or the steady state is the state of the economy where variables are at their long run equilibrium and there are no any shocks driving these variables. So in the long run steady state, inflation is at its target. So it's a pi star. So we calibrate this pi double star. Okay, let's find this. It should be, you remember, we have time varying inflation target, and we allow inflation target to variate a bit because in this case, and again, whatever specification of the equations we are giving, there is some judgment and underlying story or some historical period where we are analyzing. For example, in this case, when we are looking at the economies during the COVID, so we think that inflation target a bit lower. From the long run equilibrium. That's why we allow some deviation of the target. But it goes to pi double star US and pi double star Euro area. Let's find this. Yeah. In the calibration block of the parameters, we set it 2%, which define targets for Fed and ECB. Okay. We are saying that the varying inflation target equals to long run inflation target, and the inflation equals to inflation target. What is also specific in the steady state is that all the gaps are closed. So the output gaps are zero, and in steady state, we assume the perfect credibilities for both US and US Fed and ECB. Inflation expectations, again, are
so just to be clear, what's going on here, right? Because in the euro area, okay, the long-term inflation expectations were at most 1.5 before COVID, and then after, in the early phases of COVID, they actually ratcheted down further. So this is the perceived inflation target, right? That we're playing
the one
here.
in the here.
And so the parameter on the lag of in the inflation target equation and stuff is very large. I think like almost one and stuff, right? So this allows us to put an almost unit root into the model, where basically the projections over the next 5-10 years will be significantly lower than 2, like 1.5, for example, uh, without actually putting a unit root into the model, and uh, uh, so it just simplifies it, so you don't have to uh, leave stationary world of the stationary inflation world, and but at the very same time you can control the perceptions of inflation over the next 5 to 10 years and so on. Um, so it's just a little trick.
Yeah. Thanks, Doug. So and the rest of the variables or the gaps are zero, or all the changes are zero. So the change in the interest rate. So these are definitions, but it doesn't matter in steady state of the model in this block. We need to define them. So the real interest rate equals to bar, so which are neutral rates, and the nominal interest rate in the steady state equals to real and plus the inflation target. So here are term premiums, and as you see, we don't need, any derivations, any difficult steps or many steps to come out with the analytical calculation of the steady state. In some type of models, let's say the simple DSG, you even need to do by hand some calculation to to calculate the steady state. And for big models, you cannot analytically find the steady state. That's why you are using the numerical. In a case of GINF, you will see that the numerical method is working. Here, everything is pretty clear, like the long run interest, let's say 10-year interest rate equals to the expected path of 10-year short-term interest rate plus term premium in steady state. And the short-term and the expected path of 10-year expected path of short-term interest rate is just interest rate short-term in steady state and inflation. Nothing difficult here. All the
So, I guess I have a question. So when we first started playing around with Diner Julia, there was a bunch of bugs in it, right? And so Michelle would basically have to fix those bugs and so on. Has it gotten to the point now where uh, like you're still finding bugs like that for models like this in GIMP, or is it basically just a question of us debugging things and getting the errors out?
You mean in Julia
Yeah. So what I'm wondering is like, is Diner Julia now? Like, have they been fixing a lot of the bugs, and is that why it's
so
possible to do it? Yeah.
during the last 2 years, me and Dacia, we have been working with Michelle, reporting all the bugs which we were able to find, and Michelle fixed most of the bugs. So for monthly models, for our monthly models package, everything is working well. For Endocrat, it's working well, and I can't report any bugs at this point. But we need to try the different varieties of models and tasks to find all the bugs. And currently, I'm trying to make the GIMP working. Let's see if it works. I will be very happy, uh, but if it doesn't work, we will report the bugs, or all the bugs step by step. Okay. Now the rest. So the shocks are zero. I mean the autocorrelated. Autocorrelated shocks are zero, but here we don't need to calibrate IIDs because the INR automatically takes it zero. And there is some growth of GDP long run of the unemployment is in the Nauru level. And also we're calculating the probabilities of the high and low inflation regimes. So when the economy is operating at the steady state, inflation for longer period staying in steady state, there is no any probabilities of being at the high or low inflation regime. So these are zeros. Now we finish here by semi-comma steady state block, steady state model block. Then next, we are defining the loss function or the block of the US Fed. So we are choosing the loss function here. And to do that, after this steady state model log, you are writing planar objective. That's the dinar notation, and you are choosing your loss function, the form of your loss function. Of course, this loss function should be quadratic. Here you can see quadratic deviation of the inflation from target of the output gap. But here for the case of the Fed, we are choosing that Fed cares about the negative output gap and doesn't care about the positive output gap. That's why we have y neg. So putting the negative part or the negative values of the output gap in the loss function. And this is more or less consistent with their approach of doing monetary policy. And we are saying that don't allow very huge jumps in the interest rate. That's why we are putting as another component of the loss function, changing the policy rate and also the price level. Okay, because Fed is doing the average inflation targeting and they are looking at the price level. And then next second row should be Ramsey model, and in the parentheses planar discount 0.98 and instruments equals RSUS. So we are saying that what this thing is doing, the Ramsey optimization. Let's say we have 100 variables, and up to this point we have 99 equations, right? Now, what this thing is doing, we need another equation. Ramsey planner is minimizing this objective with respect to these 99 first order conditions. It's solving the Lagrangian problem and deriving the equation for this interest rate, right? You are minimizing this equation with respect to 99 first order conditions, which are equations of our model, and deriving the final equation. Then we will have 100 variables, 100 equation, but the explicit form of the equation, of the RS equation, you can see here. It's doing automatically, okay? Then we don't
So
have
I, I guess I
yes,
just want to make sure I understand that, and I want to make a few comments because one of my AUA students asked me about the loss function and so on. But so the structure is that if I give it a model at this point that has 100 endogenous variables, and I delete the reaction function for the US, so I only have 99 equations.
yeah,
And so the structure is that as soon as I then issue that Ramsey, it's expecting to complete, um, add the last equation for the interest rate. Okay, so I got that.
yeah.
On the
Uh,
loss function,
Yeah, but the thing here, I think, and very important that when we are using the loss function approach, the final form of the RS equation or the reaction function, you cannot see that explicitly. So the Ramsey is solving, and you can get some crazy, I don't know, the equation which has uh, tens of rows, and there are a lot of things in it, and you can see explicitly how it's reacting to what it's reacting.
okay. I just wanted to say something about because you kind of jumped over the objective function a bit by just saying that the Fed does average inflation targeting. So when it's applied for the US, okay, we're applying it in the spirit of the way that Rick Clarida would do this. So that price level gap term there is just something that you can set in a discretionary way by saying if the by just initializing the price level gap to say, let's suppose that it's like -2, okay, when you're starting the simulation. What it's going to then do is make the average inflation rate a little bit higher than the target cumulatively by 2 because it's going to try and catch up. And so Rick Clarida, when he described how they're doing this, not like they're committing to a price level target, but from time to time they they might want to use some discretion. And the way that he described it is he would add some overshooting, okay, to the model in those situations where he thought that that would be good for stabilizing the economy and providing a solid anchor. So he listed off the names of variables that he'd be looking at. One would be long-term inflation expectations continue to be anchored to the target. In other words, people expect that inflation is going to go back to 2%, and that medium-term inflation expectations were anchored. So the reason I say that is that I think and the other thing that's weird about it is that it's asymmetric. Like it has negative output gaps. And so it's like they care about full employment, but they don't care about overheating and so on. So this loss function is just a beautiful way of drawing lines when the structure of the economy can be evolving over time because of credibility and so on. So you just want to think of this loss function as something that allows you to draw lines for the expected path, the policy rate that look good. Okay, and to use a term beyond Quickstat at the Norges Bank. But again, you don't have to follow this line. There's also uh, another trick, or there used to be a trick that allowed you to fix the interest rate equal to some specific value, or it could be the path from something else. But I don't see that in the objective function anymore. Like there used to be a term where there was also a deviation of the interest rate from the desired interest rate. So we might want to
Okay,
put that. yeah, we might want to put that back in, right? Because that would allow you then to tune the interest rate for some period of time, like a couple of quarters and so on.
We
So
have
you,
that, Doug. To
yeah,
be honest, let me let me show this to you. It depends on the experiment we are working
I see.
here.
So you've got a
For
loop.
for example, in case X,
All right, good.
where we here you can see this deviation of interest rate,
Yeah,
or we call gap, and in this way we are tuning the interest rate. So it depends on the experiment we have. Yeah, here in case X I have.
I see. Okay, good, good, good. So I just wanted to say that there's two ways that you can think about this loss function. One is that you're trying to mimic the behavior of the Fed.
Yeah,
Bob Tetlow in Georgia a few weeks ago said that the Fed was the only central bank in the world that actually does this level of sophistication where you use a loss function instead of a reaction function, and obviously that's not true because we've been using it for quite some time. But there's two ways of thinking of it. One is think of it actually as a policy rule that you're investigating, that you're actually considering as being, um, something that you want to commit to. And then the other way is to think of it like Rick Clarida thought about it, which is just a trick that allows you to impose discretion from time to time that says that you want to overshoot. Reason I'm saying that is Giannis Helikas thinks that for Armenia that we should possibly take this price level gap thing seriously. Just have a very, very small weight on it, just a very small weight. And the idea is that as he argued that even if the whole modeling framework has been designed, to deal with this credibility problem so that you don't lose your credibility, that you don't do what happened in 2021 by like the advanced economies did by delaying uh, the increases in interest rates. So despite the fact that you've got all that machinery there to protect uh, making systematic errors and allowing that to erode your credibility, you might want to have something specific, that says that if there's any, you know, anything incorrect in your modeling assumptions, which of course there will be, that it's good to look at, what the actual results have been. And so if inflation on average has been higher than the target, you might want to feed back a little bit on that because one of the reasons that it might have been higher than the target was not just because of bad luck, but because you had something wrong in your framework and you were making, some sort of systematic error. So I like to explain this like when you're driving a car, you turn the steering wheel and then you turn it back after you've overshot your spot. And so human behavior is very much like that, right? We never plan to go asymptotically back to some spot. We try to move away from danger, and then we realize we've overreacted a little bit. And so I think there's a very interesting research project here to investigate model uncertainty and so on. Plus, the other thing about this stuff, the way that you've done it, I guess, is you can do really super neat things that I used to do. My God, I want to say over 30 years ago when my modeling actually was much more sophisticated than it is now, where you can have like the true model, the central bank's model, and even the private sector's model. And you can have, so the fact that we now have all these loops and these abilities to turn things on and stuff. And that would be super cool because we can go back to a lot of the old research that we did on looking at model uncertainty. So in other words, you say, let's suppose that you think the model is one way, and of course it ends up being a different way. And so you can study the implications of of really neat things. And of course, now that it can be done as a mixed complementarity problem with with a loss function, that that kind of research is it should just explode uh, um, because of the ability to be able to code up the models relatively easily and obviously to compute them. I'm interested, I guess, do we know the actual algorithms that are taking place that are being used here? Like we know
Yeah.
that in Dynamic MATLAB it was extremely efficient. But do we know if they're the same algorithms in Dynamic Julia?
Like I know everything is the same. The algorithms are the same, both in Dynar Julia and MATLAB, because when I tried to check that, run two models, both in MATLAB and Julia, and compare the result, and I can get exactly the same for some of the policy experiments, which I'm not sure, but I can conclude that the algorithms are the same.
Can't quite conclude that.
Uh,
Conclude that the two algorithms found the same answer, but what the question I was asking is, do they find the answer like in a similar way? So when it's really working and you're pushing up against inequality restrictions and so on, the question is, does it have the robustness? So if it, in the case where it can find solutions, we'd hope they'd find the same solutions, but that doesn't tell you the same algorithms were used to find the solution, right? So I'm just
oh, okay,
wondering
okay, I understood.
because
I will try to check because the documentation of Julia is very poor.
yeah. So the question is, I mean, we'll learn that if you just give it a really difficult problem, right? Just give it some gigantic shocks or whatever, and then that really stretches it in Dynamic MATLAB, and then see does it does it work the same way? So, for example, that max function in the interest rate reaction function, what is that? Like, what is it actually doing to impose that inequality restriction? Is it doing homotopy? In other words, is it finding functions to approximate that kink? When you hit the zero constraint, uh, or so there's. It's just that if we should really become experts, I think, in terms of what algorithms are actually in both versions and if they're different. Okay, because
Okay, yeah, that's important point. I will try to elaborate that and find as much information as I can. Um, yeah, and do the crazy experiments as you said. Um, okay, so this kind of uh, yeah, the block for loss function, and here we write the init val for the policy instrument, and you don't need to you shouldn't write down the steady state of the interest rate for Fed in the steady state model block. Then
is that a knit val because of the Ramsey? Is
yeah,
that why?
yeah,
Okay.
yeah. It's actually it's a steady state. It's not the init val, it's
I see.
steady
Okay.
state,
Okay.
but the notation is a init val
Yeah, okay.
after the Ramsey problem. And when you put your steady state value in the steady state block, it will not work.
I see.
Yeah, then okay, let me see what. Yeah. Now, guys, in this code we are using to replicate the result which Ani presented, going back to initial break of the COVID when both US and Euro area entered the COVID period, but there are some differences between these two countries. As Doug said, the long run inflation expectation of Euro area were quite below to their long run inflation target. They were 1%. But for US, it's 2% close to the target. And when we are looking at the historical developments of the credibilities for both Fed and ECB, we think that ECB entered the COVID shock with lower credibility than the Fed, and also ECB was at the ELB constraint, the interest rate, but differently has some space to further kind of make monetary policy conditions easier and react to this shock. So we calculated these initial conditions of the credibility using long-term inflation expectations and all the analytical things which Ani presented, all these probabilities of high inflation regime, low inflation regimes, and having that, we calculated credibility index for Fed and ECB and took these initial conditions in our simulations. Okay, that's kind of very broad view of the experiment, and let me here show what conditions we what initial conditions we here we set to do this experiment. So first of all, you need to write down the block called histval. So what does it mean? We are saying that we want to do simulations not from the steady state, but from some point. And here we are interesting at some historical period, as I said, the initial stage of COVID, where the economy, both for US and Euro area, are not at their steady state. They were more or less close to steady state, but not at the steady state. And here we need to define the initial conditions from which we are starting our simulations. So zero here, because the model is quarterly, here we say that, for example, CUS, this is the credibility of US, zero. Zero means first quarter of 2020. 0.89, and for Euro area, a bit lower. Okay. We are saying here that term premiums, both for US and Euro area, are lower because before because interest rates were lower and they all these QE programs were in place, and looking also at the estimates from from Fed authors like Reichschneider, we can see that the term premiums are lower from their historical, let's say, equilibrium levels or steady state. We put 0, which means that they are, except the expansionary policy from the coming from the expected path of the policy rate, but also there are some other expansionary policies like asset purchases and other things. Then, yeah, because let's see. Yeah, for US for state for the effect of the US real interest rate on the at the first quarter, we assume again close to 0, and for euro area it's a bit even contractionary because interest rates for a prolonged period of time were around 0, and we had some positive inflation. I'm sorry, the inflation was negative here, and we kind of calculated the difference between the interest rate between the nominal interest rate and the inflation expectation, and come up with the real interest rate gap and trends, and here these values. And the long run, which is very important, the long run inflation target for US and euro area, they are, time-varying inflation targets. They are at that period looking at this analysis of the US long-term inflation expectation, and for euro area, they were significantly below from long-run inflation target for euro area, around 1, and a bit lower for US, like around 1.5, if we put here at the initial conditions. So we are starting for US. The current inflation values were close to the target, and for euro area, they were significantly below, around 1%. These are close to historical developments, and the current policy rate 1.25 for euro area and 0 for Fed, and 0 for euro area. Here you can see something different for inflation. We put also the -1 and -2. And why we did this? Because in this Hist-Val block, we should define all the state variables which drive the model. And what state variables means, which can affect to the dynamics of the model, or otherwise in a state space or reduced form representation of the model. These are the variables which affect to the dynamics of the model. And for some of the equations for some of the variables, some state variables enter to the policy function with multiple lags. For example, inflation with 3 lags. That's why we need also to define the first and second, put the value for the first and second lag, which is in this case the fourth quarter of 2019 and the third quarter. Okay, and for some variables, let's say price level is we should also declare the -3.
So it would be good if we went through an exercise, right? And said, okay, it's February 2nd today, okay? It's a quarterly model, right? And so we could say, okay, the past is the fourth quarter and the third quarter of last year and so on, right? And I just think, and then just ask, well, what are all these state variables? What are the lags of inflation and interest rates and stuff? And so maybe what we could do, I guess, is tomorrow we can make all those calculations and stuff, right? I know you're going to be on the GIMP course, but what I'm saying is that one of the other students that won't be on the GIMP course can basically do all those calculations, and then we'll do a market reference scenario and a case A and a case B, and I think
But
that yeah,
during all that monthly module course, I remember I have a lot of videos on that. I explained step by step how to get the state variables of the model. So we can do that also during the next week, going through all that steps. Yeah, I can do everything.
wonderful.
Yeah, yeah. Okay, maybe next week then I will show how to for maybe for other models or even for this model how to identify
So,
the.
okay, good.
Okay, and so for example, this I guess the unemployment is not the state variable, but just for reporting, we put some initial condition, and so we can then draw and plot the unemployment just for reporting purposes. If for state variables here in dinar you don't put your value, dinar takes it 0, and it will significantly affect if you don't consider the initial conditions for your state variables. It will take 0 and will affect to the results of the simulations. Okay.
So if you put one of those sysbills in, it'll screw up everything. So it's all in. Okay, like yeah. So that's a common mistake. You can't put one or two or three. You got to put them all in. But
Yeah. Yeah, of course we tried and tested all this. For some cases, it destroys the results. Okay, now these are initial conditions or the dinar histval command, histval, and then again end. And so having these initial conditions, then we are saying that COVID shock hits. Okay, for US and Euro area. And here we use the different combination of shocks to think about this historical period. Of course, we have some negative demand shock, both for US and Euro area. We have we have some negative inflation shocks. So all this. Let's then come back to these shocks when we look at the graphs. Okay, let's finish this. Run Dinar Julia, get the results, and then look at the shocks again. And here, what is also requirement to set here is Ramsey constraint, similar to the block for ECB with ZLB reaction function constraint. Here we have for a Ramsey constraint saying that don't allow the nominal interest rate goes below zero. Okay, that's the way to write down the constraint also for the Ramsey problem. And usually we put it after the shocks, just Ramsey constraint, the instrument which are using, and put the constraint. You can put whatever you want. And then, this is the perfect foresight simulation. And for doing that, we cannot do yeah, you need to. So this comment, you need to remember this, or just from codes you then can use for your own models. Just perfect foresight setup, and saying that do 80 periods of simulation. You can change this number, and after that you need to choose the solver, perfect foresight solver. LMMCP is for mixed complementarity problems. So our setup is a mixed complementarity problem. That's why we need to put this LLMCP. There are other solvers as well. You can, for some models, don't even use this perfect foresight solver. Don't define solver. It takes some default solver, but not for mixed complementarity problem. But it can solve nonlinear models. Now, this is what is Dynar code, but how we are running it in Julia. And you should have this endocrat simul 2020 GL. Now this is the GL format or Julia format. Okay, and let me go briefly. And what this thing is doing is running the model, which is only one row. Okay, and then the rest of this is for reporting, how to create graphs and plot. Let me go step by step. When you are in your virtual environment, okay, in packages, and you have installed all these 5 packages, data frames, Dynar, PubSolver, plots, and dates, you need to say using, so you have installed, but you need to declare, to say, Julia, using Dynar, using PubSolver, using data frames, using dates. You need to do this. Is kind of activating these packages or using these packages for the certain tasks. Now the way to run the Dynar code is the following. Context equals head the Dynar and the name of your model. So it should exactly match the name of the model, which is quarterly US domain.mod. You can, if you forgot this, don't worry. Just go to GitHub page as I showed, Dynar Julia GitHub page, and here you can see directions. Running Dynar is by using context equals Dynar double upper commas and the link to the model. Nothing else. But because here we are using the VS Code and we are currently at this folder, we don't need to give the full link to this. It understands that we are at this folder. Yeah, in Julia you can, in your terminal, you can type TWD square brackets, enter, and it shows in what directory we are currently operating. So it's the users desktop course BPP February 2025. Okay. Then we are at this folder, and in this folder, I have the mod file called quarterly US EA and OCRE 2020. So context, then so it's running. Even you can run it manually in your terminal. Just copying paste. For those of you who haven't installed all these programs, it will not run, but when you do all the steps properly, it will work. Then the next stage, and these things are more or less are mostly after this command, everything is Julia specific. So for example, in MATLAB, you all know some ways of how to construct the graphs, how to get the results, from model. So yeah, now here we're running this code. Context by this command. Then next stage, what we are saying that save some df, call it df, and take. Okay. Now all the results are saved in context. You can type here the context, and it gives you everything. So all the information like calibration, initial conditions, simulations, everything. But to kind of get all the results, we are interested in getting the perfect foresight simulations. And here's the link to get that. From context, we are going inside the context results, inside the results, model results one, inside that simulations one, and data. So when we run this, okay, what we will get, starting from one to going to the end of the period. So this gives us the table or the values of the simulations for all the endogenous variables. Okay, in DF now we created this DF. In DF we have IUS, and here's the initial conditions. You remember we started for US inflation 2, for euro area 1, output gap 0, euro area output gap is 0, interest rate the first quarter of 2020. 1.25 and 0 for euro area. And we have, that means that we are starting from the fourth. The fourth point is our initial condition here. And here is a missing. Why? Because we have 4 lakhs, 4 lakhs of the initial conditions, declaring the values of the state variables in the -1, -2 lakhs. Okay, so this is the table. Then what we are doing here, why we need this date, all these packages you install, data frames, dates. So we use this data frame package to bring or to numerate the output of the Dynar Julia into some structured structured form, starting from one and going to the end of the simulation. Then we are creating some we call time index, and here we are using the date package and saying that create some timeline which we further will use to create the x-axis of time based on quarterly frequency, and saying start from the first quarter of 2020, go quarter by quarter by 1 quarter up to 2030. Okay, and take the first 40 of these. Let me show how it's working. Okay, time index. We started from 2020 first quarter, and taking the first 40 of these will go up to the fourth quarter of 2029. Why I am doing this? Because I'm going to plot the 40 quarters of the simulation of 10 years. You can write here, for example, to 2015, and again run, but take the first 40 of this. You will get the same. It goes to the same. This is for plotting purposes. If you take one for starting from 1 to 30, it will go up to 2027. Okay. Then format X label. We want here because the default function of creating the X file will plot year, month, day, hour, minute, seconds. Here by this command we are saying that that make it shorter. Then some set of the variables which we are going to plot. You can create. So here this reporting part is poor, and I hope that you will help us to create some nice reporting package. Here is just for illustration. I'm going to create 6 figures, putting there the main macro variables which we are interested in, and because to make the kind of figures much more beautiful, I'm going to put 4 variables in each figure. Otherwise, have 2 by 2 size of the figure. Have 4 subplots in each figure. So I'm choosing the set of the variables figure 1. I'm saying take the US interest rate, euro area, inflation for US and inflation for euro area. For the second set of the variables, this inflation expectations output gap. For the third, long run output gap, and the long run interest rate gaps, and unemployment rates, term premiums, year-over-year inflation, and some exchange rates, nominal exchange rates, and the real exchange rate gap. Then what we are saying after defining this, for example, for the nominal exchange rate, I'm going to plot some Um, because in the model the exchange rate is just the deviation of exchange rate from steady state. And to go back to the data or to represent the historical dynamics of the exchange rate, I am starting from 1.09007, current, uh, which is the current level of Euro USD exchange rate. For €1 in the market, you can get 1.1 approximately USD, and for €1 you can get 0.9 euro. And then I'm taking this as an initial condition for the exchange rate and multiplying by the exchange rate gap, which I get from the model to kind of get this exchange rate dynamics. Okay, for example, this Euro USD. What I'm trying to do is to build this to build the graph of the exchange rate, which will be close to actual. Or otherwise, we can do these steps inside the model, but I'm showing you that in the reporting part, you can build the index of the exchange rate out of the model variables. So these are variables inside the model, okay? Then the next thing, similar to the, like, to get to make the graphs to put some limits to the y-axis of the graphs. Here we can use this command y-lim dict and say that in my upcoming figures, plot rs in a range from 0 to 3. For US and for euro and for inflation, for example, plot in a range from minus 0.5 to 3, and for other variables. So how I'm using this when I'm running without these limits and get some graphs, then usually I'm thinking about some volatility and uh, to make it nicer to tell stories. I'm coming up with some limits which I want to see for these variables. So similar to this, for example, in MATLAB, let me show you. Yeah, for example, you can see that these are very beautiful, having the interest rates, for example, from plotting from 0 to 3, covering visually this range for both, and for inflation and for other variables. By default, it will plot. It depends. You can try that. And here,
I guess
yeah,
I want to ask you some questions here, okay? Because by July, Simon says they'll have Python done Air Julia, okay?
yeah,
And so Python will be driving everything, but it also means that you'll be able to use Python for things like charts and reports and stuff like that. So my question is this: like based on your experience playing around with Julia, like do you have any preferences for where the charts would be done? Because the idea between Python, Dyna, Julia is that the Julia would do all the back end stuff because of its speed. But I'm just wondering, should we start, like, for example, if we do a simulation in Dyna or Julia now, we could do a Python chart. But do you have any, what do you recommend that we do?
Yeah,
Should we start?
I would like to see Python charts. I never did that, but based on my experience with Julia, it's very difficult in Julia, and it's very not user friendly for me. I think in Python it will be better because I spent a lot of time trying to figure out how to get these figures, how to change them, how to change the type, and it's very difficult. And I don't like I don't like these graphs. Yeah, I will run and show you. You will not like. I think in Python we can do better reporting.
So we could just think of it as inside Diner Julia. Can you run Python? Um,
I
because
don't
in other
know.
words,
I don't know.
okay,
But if we get these results, for example, as I said, everything we need is here in this context.
yeah, yeah,
If
yeah,
we
yeah.
get this and kind of use the Python innovated, it can get these results and then create everything there. For me in MATLAB it's better to create the figures. Here it's much more difficult for me, um, and I don't like these graphs.
Okay, well, that's great to know. So we can basically jump straight to Python, like just use this for calculating and doing rough stuff, and then and then and then we'll do the fancy stuff in Python.
Maybe here also we can do, but guys, I need to help me. It's very difficult for me to work on design of the graphs. It's a lot of coding work, and I can help them, but all this computer work.
But if it's in Python, that means we can use ChatGPT, right? Um, to do all the coding and stuff, right, in Python, right? So
Yeah.
it, I think I think we can play around with something and take that part. Okay.
Yes. Uh, that's a very great point, and I will be happy to see that some progress here. Okay, then when we are setting here some limits and or the range for the uh, y-axis for all the variables, we are going and saying plot some figure, and it should be 2 on 2, or putting um, four variables in the figure. And what we are saying that variables for here, it's similar. It's very similar to MATLAB. You can manually create all subplots inside the figure, or you can do it by loop. Here, for example, we are using the loop for and using again. It's similar to MATLAB. We are saying that use the list of variables in fig1 which we defined. Let me show again. Fig1. Here, interest rate and inflation. Okay. What we are saying that, and then plot time index, which we created here. Then use the data. The data, as you can see here, using this figure, using this command dict, we put in data dict all the variables starting from 3 to 42, which can can be consistent to our initial condition because we have additionally 3 points for each variable because the longest the longest log of state variable goes to -3. So 3 is the initial condition. First thing, take all the variables from 3 to 42. Otherwise, 40 periods or 10 years. And here the same, we are saying that take from 1 to 40 the quarterly dates. Okay, so this sizing should be similar. 40, but 4 times here starting from 1 to 40, and variables from 3 to 42, which is 40 periods. Okay, we are saying that take this time index, take the data, title of each subplot, make the name as it is in a Dynar code. Don't do legend. And also plot use these limits of the y-axis. And also, which is very important, and I suggest you to do, is saving this in PNG. So just putting this command save fig plot grid one, which is this plot grid one, and name the figure. You can save this figure in PNG. So it will look like this. Okay. Now, and then we did we created the second figure with other variables. It's exactly the same for here 6 figures, and then we need, if you install everything correctly, you can open this Julia code and just run. On the first try, it might take some time, like a couple of minutes. But on the second try and on a third and other tries, it should take like seconds to complete, and it's faster than Dynar MATLAB. Okay, and it also automatically plots the figures, but also it automatically, as I said, using this save fig, it saves inside the folder the figure in PNG format. So I can open the first one here and how it looks like. As you remember, in the first figure, we are using the interest rate for US, euro area, and inflation. And you remember this range is plotting exactly from 0 to 3, and here from -0.5 to 3. And here you can see the time we are using in the quarterly frequency. Yeah, that's how it looks like. Not bad, but I think our students can create better charts in using Python or even inside the Dynar Julia.
It's great, like for rough charts that you can get, and then you could, when you want to do something professional, and we could bring Python in and stuff. But this is wonderful, I guess. I remember the very first time uh, that I actually got an algorithm to work, like what you're doing right now, and uh, I think I worked around the clock for 3 days just generating results from models and stuff. I was so excited, and I'm getting the same excitement, by this. And this is an incredible amount of work, both by Michelle and yourself and Nasia, and I'm I'm very pleased, very happy that we can now have something to do some pretty serious calculations with. I can also understand how difficult it is for somebody inexperienced because there's so many choice in this model. Like, there are so many choices that need to be made here, and so I can kind of understand a little bit why when people come from academia, they just want to estimate them. They just want to, and not recognize that most of the time you just get sheer nonsense by just estimating it, unless of course you have someone extremely experienced that's checking, you know, exactly what's coming out of the computer and so on. But I think the way forward is that we just have to go kind of inch by inch and sort of start training people, uh, to get them to understand the properties of the model, uh, and basically to get them to build their own little model. I think that's, what do you think? Yeah, I mean, I yeah, after you build a model, or after you build maybe three or four models, then when you go into someone else's model, it's much easier. But the idea that you kind of start off with someone else's model, I don't think you truly uh, understand it as well as when you actually build the model yourself and so on.
Yeah,
Just
we can do that during next week and kind of also merge these two courses and do the different stuff and can call it the modeling course, or where we can start from simple
yeah, yeah,
ones
yeah,
and then go to GIF and
yeah, yeah.
application on more policy relevant and real life issues. And yeah,
Because when
we,
you work with a little one too, then we'll be able to ask, well, can we get some Python? Uh, uh, can we get some Chat GPT working on the code, for example, right? Because
yeah,
you might be able to take a little model, and if it's small enough, stick the working code into ChatGPT, and then possibly you can start talking to ChatGPT saying, I want a model that has these different characteristics, right? Because the model is just some endogenous variables, and some parameters and stuff like that. So, everything, everything we should be able to train ChatGPT to do fairly easily and so on. Uh, and including documentation of the code, like all the weird stuff, like
yeah,
um, the term initval. There's just a lot of uh, kind of historical the historical use of terminology and stuff that isn't very intuitive and so on. So we can try to do documentation at the same time. But this is wonderful. Is there anything else, or because I
yeah, yeah.
yeah, there's
We have also other. Can we have a like 15 minutes, 10-15 minutes break and then continue with the second?
okay. Thanks.
Start with maybe questions and then
Yeah.
proceed to the rest of the material. Okay, thanks.
Thanks, I guess. Wonderful.
Should we continue? Are you here?
Yes, hi, Gustin.
Yes, I guess we can continue. Okay. So now who can run this in his or her own? Annie, you get the same results?
Not yet, hi, Gustin, but I'm trying to run now.
But yesterday you get right?
Yeah, yesterday yeah.
Anyone else get the same results as me? Okay, let me then send you other codes for other simulation. We will go through this simulation, then construct case A, B, X scenarios for Okay, I send you codes. You can also download these codes from your emails and put at the same folder as we are in. Let me share again my screen and continue. Okay. So what we did here is replicated the results which we have in the Oxford paper. So this historical period where the stance of the monetary policy for the Fed is much more favorable. It had more credibility compared to ECB, but also some policy space in a response to the COVID shock to further decline interest rates and solve this problem. And additionally, what I wanted to show you is that these differences in the monetary policies allows in this situation Fed to depreciate USD against euro. Here you can see this is the actual and this is model implied. From 1.1, it depreciates around 10%, which allows further positively affects inflation and inflation expectation and bring back inflation faster than for ECB. ECB keeps the interest rate for a prolonged period of time at the ELB, but instead Fed because of higher credibility and because of conducting the loss function, it depreciates the currency and affects much more better in this situation. But instead, ECB keeps lower interest rate for prolonged time and stay at the lower inflation. Here you can see inflation and inflation expectations significantly below target, but Fed could bring back inflation to the target very effectively and quicker compared to Fed. So here we get these figures. And then so Annie and Doug talked about this a lot. If you have some questions at this point, we can discuss and then proceed to the next part when we are going to use the same analytical framework to construct case A, B, market reference scenario, and case X for both US and Euro areas. Even if you have some technical questions at this point, we can discuss even related to the installation of these packages and all other questions. Any questions? Annie, do you want to add? Yes? Diana? Yes.
Yeah. So hi, Kashan. I just wanted to check this is a Dynar tool, yeah, and as I know, our students didn't yet install it. So can we run this code in Python editor? I guess we have just Anaconda and Navigator at this moment. Can we run it there, or we need to change the something in the code, or they can be done with the AI? Can we just ask AI to change to the Python code and run it there?
Diana, you mean run Python in Python Dynar? So,
Yeah.
okay. I'm not sure that at this point we have that. We can use as a background Julia, then plot the results in Python, I guess. I don't know
Ah,
to do that. I never used Python, but the underlying process of solution of the model at this stage it should be in Julia or MATLAB. In MATLAB,
okay.
well, but because of open source software, we are using Julia. It's working in Julia, and here the reporting is also in Julia. Of course,
Okay.
as I said, I don't like a lot, or maybe we need to spend some time to make this reporting system much more beautiful. We need some time, but all this VS Code, Julia, everything is free and open source. So
Yeah,
there is a step-by-step guide how to install that from yesterday's video. So you can repeat all that steps. But in some cases, we got problems in installing Path Solver. For example, in Sophie case, Sophie, did you try again? Or maybe
I
you
try
found
with
something.
my
Yes,
computer.
so I tried also, Asia helped me to run some other code to solve this problem, but yeah, I wasn't able. Then I tried to delete, uninstall, and install again, but yeah, it did not work. So
Again, the same problem. You get the same problem.
yes, after the second installation, even I was not able to add data frames. I didn't really know what's the problem, but yeah, maybe we can check it tomorrow.
Yeah, and probably we need to invite some IT guys. Maybe they will solve because yeah, as I understood from the problem, it's we need to have some IT knowledge, deep IT knowledge to figure out that, or or use ChatGPT and follow all
I use
instructions.
ChatGPT basically.
Yeah, it was the same kind problem with my computer. We need to change something in Windows, but I didn't understand the problem.
Yeah, change something in Windows. Yeah.
Yeah, something must be changed, but I didn't understand exactly what part. So that's why my question was about height.
I think it's like some license problem or something. It's not related to Windows or Mac. So there is something in GitHub that that you cannot install with that with GitHub.
Yeah,
What you
basically
mean,
the
Hani?
problem was
What you mean?
we
What
did.
is that?
Do you mean the license code, Annie? Because we tried it as also like to use this
There
license
is a
code.
license code in GitHub, I guess, that like you can add, and then
We
I
use this code as well. And there's a problem when I try to add this test solver manually by the link. Yes, VS Code writes that it is not able to connect to GitHub.
I will try to look at that license code, and I will also send some of them, whatever I find useful.
Yeah, let's then today after this course or tomorrow try to figure out that, because I also tried in Doug's computer, again the same problem as in Sophie's case, the same problem. Okay, Ani, but did you try in Mac? Is working?
Yes, Hakan, it is working. I have run successfully all the scenarios, put them together.
Both scenarios and this historical simulation, right?
Yeah. So it's the market reference case A, B, and X scenarios together.
Okay, good. Very good. Now, so if we finish this part, let's move on scenarios. Ani, can you for 5 minutes share your slide on scenarios?
Sure.
And talk about the assumptions of the scenario, and then we will try to get to replicate that in Dynar Julia yesterday, which you showed. Yeah, but in presentation, in your presentation, when you were talking.
Okay. Yeah.
Here. Mm-hmm.
So the case A, B, and X, right? Yeah, here.
And yeah, can you kind of give us overview of the assumptions and what we...
Yeah, so basically we have these 4 scenarios. First one, as you know, we are moving away from baseline scenario, having baseline, which can give full sense of assurance to the public and financial institutions about the future, and also it can restrict our flexibility in decision making. And on the other hand, we are implementing market reference scenario instead. This reflects market's expectations. And nowadays, markets expect soft landing. From the Atlanta Fed's market probability tracker, we can see that this interest rate path continues to land softly, as I can say like that. But so if we compare this current estimate of the neutral rate with the previous one, we can clearly see the upwards revision in that. So this relates to the effects about the demand, strong demand in the economy, recent policy shifts, and so on. But still, this soft landing continues to be relevant. And this market reference scenario can act as a benchmark for our alternative scenarios, such as case A, B. So in the case A scenario, central bank requires to have higher interest rate path than what is currently priced in the financial markets. That is the market reference scenario that we have. And we can see in the case A scenario, this federal funds rate is way above compared to the market reference scenario. And this case A is motivated by the events, by the ideas that there is a big relevant demand shock still going on in the economy, and this is because of the massive asset price accumulation, asset price increases, and household wealth accumulation during pandemic. Also, these recent policy shifts like tax cuts, tariffs, immigration policies, all are stagflationary shocks, and they prompt these case A type considerations. And so in the case A, under the case A scenario, we will have higher inflationary forces and more persistent. And to curb these inflationary forces, we need to have higher interest rate path. And doing that, we will create a higher sacrifice ratio in terms of the unemployment rate we can see here. And we can see that in this case, we also lose some credibility. And yes, and also in the case A scenario, there is a euro appreciation going on because Euro's depreciation, Euro's depreciation going on because as the Fed will raise the interest rate, dollar will appreciate because of the capital imports. Sorry, the euro dollar will appreciate, because of the capital imports, and euro will depreciate, yes. And this is what we can see in the case A scenario. It goes, it decreases, meaning that euro depreciates. So in the case B scenario, we require to have lower interest rate path, as you can see, compared to the market reference scenario. And this case B can be motivated by asset price correction. So most of these increase of the asset prices is estimated to be a bubble, and anytime it can burst, resulting in a crisis-like scenario, and have deflationary forces intensifying in the economy. So we also have external factors like Chinese economy slowdown, and this can also reduce the external demand for the US economy and create case B type considerations. And finally, we have another version of case A, I would say more extreme version of case A scenario. This is the case X. where we assume that Fed will follow this soft landing path for a while, and then it will increase the interest rate, delaying its decisive policy action. And this hesitation, this delay will cost them way higher increase and a more persistent increase in the interest rate. So we can see that this delay will result in higher increase in the inflationary forces. And in order to re-anchor expectations and tame these inflationary forces, they have to overshoot this interest rate even higher than in case of the KSA scenario. So this is like a brief summary of our scenarios.
Yeah, thanks, Ani. Now, the idea is to use the model which we analyzed to build this scenario, and I will show how exactly to do that in Dynar Julia. You all got, right, codes which I sent to you. Okay. Now, you can put all the codes in the same directory as we are working in, and so these scenarios 2024 Q4 is a Julia code to run the entire system. But let's go and look at the assumptions, how we put the assumptions, as Ani said, of case A and case B scenarios in the model, and then I will show how in Julia run like simultaneously all 4 codes, how to get results of the output and plot the results in a table, or in a figure. Let's first open the market reference scenario. And what you said, Ani, what is the market reference scenario?
This basically reflects market expectations, what currently they expect about the economic conditions.
Okay, yeah, that's good. And one of the critical components of the market reference scenario is, of course, the expectation of the policy rate. And for that, we use Atlanta Fed estimates of the path, expected path of the short-term interest rates, right? But for US, we looked at this policy function, right? But here the component. So those function is operating by solving the Ramsey problem with a lot of first order conditions or constraint and get some path of the policy rate. But how can we control that path? Okay, here we are introducing the other component, which we call RS gap US. Okay, and let's find that. What is this? RS gap. We are saying that also minimize RS gap. And RS gap is a difference between RS Fed here and RS US. Okay. We kind of introducing other variables and other things to force the loss function to follow some path which we are giving. And for constructing the market reference scenario, we are looking at the market expectations from Atlanta Fed, and we need to tune that values for the simulation period. Okay. Then what is RS Fed? We are saying that RS Fed is a sum combination of RS US, which is policy rate, and RS dot. Okay. And we are making this X varying. And what is RS dot? RS dot is a shock. Okay. Then going to the block of the shocks, we are saying that from period 1 to 10, the values of the interest rate. So it goes back to the fourth quarter. I guess it was early December or late November. We put these values for the interest rate according to the Atlanta Fed, 4.4, and then it stabilizes to 3.7. But recently this value is higher. Okay, that's the way how to tune the path of the policy rate inside the loss function. Okay, and you remember this?
May I ask?
Yeah, please.
Yeah, so for better understanding, I just want to check. We give the Atlanta Fed path here as RS dot, and we want to RS Fed and RS dot the differences minimize across the time, yeah.
Yeah.
And this is the path that we force him to not go far away from the path that we think.
Exactly.
And this is just Atlanta Fed's tracker number that we need to update each time manually, yeah?
Yeah, exactly. You said everything correctly. That's what it's doing. Yeah, we are saying that we want the model implied interest rate be closer to the Fed expectation, which is here. And how we do that? We do all these steps, but also in the loss function. In a loss function, put the high weight to this. You see, it's 10. And for rest, it's lower. It means that higher value should be given to kind of equalizing the model implied interest rate and the Fed expectation. Yeah, that's exactly what Diana said. And here, but we are saying that this X, which will be 1 for 10 periods, okay? Then it becomes 0. We put just first 10 values of the Atlanta Fed. So it doesn't matter. It's just I'm showing you the technique how to fix the interest rate in the loss function to your values, and which is very important in FPAS Mark II is having market reference scenario and the good measure of market expectation of the interest rate is a Atlanta Fed tracker. We talked about this many times. Okay. Okay. So, and these two are we define as exogenous variables, and in the shock block we give values. Here, RS dot and FX. We're assuming that they are exogenous, so in shock blocks we can give them values. Okay, so this this is very important and the critical component on building the market reference scenario. Again, this is valve. How we calibrated this, we are looking at the current developments, looking at the quarterly data, and calibrate these values. Let's say the Q over Q inflation in US, it's 1.5. It was 1.5 in the fourth quarter, which is our initial condition. I guess it's not the exact data, but it was an estimation, best estimation at that point. This is history. So I think tomorrow and during next week we will go deeper in more simple framework. We will go deeper and step by step how to calibrate this for those variables which are we can see the statistics. We calibrate it statistically. For those which are unobservable, let's say the interest rate gap and output gap, we use some judgment, but also we have some system of other models when we get all these values by running the filter, then put from filter the initial conditions here. I think next week we can cover that deeply. Here, in the market reference scenario, we put this path of the interest rate, and so that's it. All other shocks are zero. We don't have any shocks. And do exactly the same, perfect for site setup. And because again, it's a mixed complementarity, LMCP. Then case A. So the initial conditions are the same for case A. But here, here again we have in loss function these differences in the interest rates, but in this block we close this. That means that RS Fed it's a zero. It will be zero, and this by closing this block, we automatically make this part of this component of the loss function irrelevant for the simulation. Okay, init val is the initial condition 4.1. It's a Fed interest rate. Everything is same. Everything are the same. Then, in case A scenario, because it's inflationary scenario, we have kind of story of the persistent higher demand conditions. Here, compared to the market reference, we are adding some positive shocks on demand and a little inflation expectation shocks. Case B. The case B, I think the story here is that we follow the Fed. You can see it's here. We follow the Fed path, but from September path, or I can't remember it very correctly. Maybe Ani, can you remember assumptions of case B? As I remember, going back to the 2024 Q4, we there assume that under case B, we follow the path of the Fed policy rate from the expectations of the September or October, where the path.
Yeah, neutral rate was 3 around, yeah. That is how we constructed the case B.
Yeah. So here, how we put the path, as well as there are some negative demand shocks, and let me check the real interest rate, real neutral interest rate. What we change here? Yeah, it should be one. You're right.
So I have a question here.
Yes.
I want to understand the case A and case B type sizes are related to expert judgments, or we have some calculation, or we have some calculation how to understand the X size,
I think
proper
I got
size
your
of the
question. I
and
think
B.
yeah, Diana, I think I got your question, and it's about, did you use some deeper analysis to come up with some sizes of the shocks, right?
Yeah. Okay. Yeah. Exactly. Because I want
that's what we are doing in practice when are building the scenarios. In this case, because it's just illustrative, we judgmentally put some sizes of the shocks and didn't do like for case A and case B didn't do
okay.
like
I understood. Okay.
Okay. So this case B and case X, the idea under case X is that Fed is following some market reference scenario, and then in a quarter or 2 quarters, it recognizes that that the underlying inflationary forces are higher, and it's missing it. And in the initial two periods, I guess, yeah, in the initial 2 periods, it follows some market path, and then it realizes that the inflationary forces are high, and then it should react faster and much more significantly to stabilize inflation expectations. Let me open these scenarios 2024 Q4. What we have here, again, using Dynar, just all the packages we just installed, and Julia allows to write down the codes in a way that it can simultaneously run four. So we have market case A, B, X, and plot all the 4 results in the same figure or graph. Okay, for that we just define model files here and name all 4 models. Then model files. Again, it's a loop, and the idea is that we are using the loops to save all the results for all the 4 models and name it similar to their Dynar file names. So it's that's how you are doing this. And then in that you remember this DF, but here DF underscore for models for each we are saving these simulation results. Again, the link to the simulation results. And constrain the time index here. In this particular example, our initial condition is the fourth quarter 2024. That's why we're creating this time index starting from that, going by the step is 1 quarter up to 34 and taking the first 40 of that. Then we are setting here variables to plot, so interest rate, inflation, and using these model colors, we are choosing the color of the lines, blue, red, green, orange. You can also choose the type of the line, solid or dotted or whatever. Just study this. You can get a lot of information, even asking ChatGPT or just searching in Google. So what you want to do, and there is a lot of material, so you can design all the graphs in a way you are comfortable with. Then again, we are saying that want to have 2x2 graph and variables to plot are these. Again, similar to the previous case, we are running the loop and plotting all these variables and save in scenarios 2x2 2024 PNG. So these PNGs are very convenient way to put in presentation or to put in LaTeX code, so you can create your presentation or paper in LaTeX. I like this format, but you can save in other formats as well, in PDF, JPEG. In this case, we have this PNG, and then just we are running. For the first time, it takes time, but when you are running at the second and third time, it's very fast. It's running 4 models simultaneously. It finishes the market. Now it's running case A in order we defined. Okay, it finishes case A, now case B. Okay, then we have these results. After running it automatically opens it here, but also saves in scenarios. We can close even this and open this PNG here. It's the same, but you see that x-axis are we didn't get the proper x-axis. We need to do some work, but what we have here is that we have the legend, titles, and in the same graph you can see all 4 scenarios which Ani presented. Here in this code we have only for these 4, and using the same way you can add other variables of the models. Here blue line as for market, interest rate is stabilizing around long run. And for case X, as I said, initially it follows the market path, then jumps after realizing that underlying inflation expectations are higher, it jumps here. All the main assumptions of the case A and case B are for US and Euro area effects through the spillovers of the stories happening in US, and you can see that in case X, ECB has higher path of the interest rate. Okay, let's then.
May I ask?
Yeah. Now it's very good time for questions and for discussion. Then, yeah.
So the only thing that I couldn't understand here is the red line in US inflation. So as we can see, all of them are going down, and after some period, maybe 1 or 2 quarter, just after that, case A is running to higher level. Yeah, is it okay?
You mean this?
Yeah, in
this
that
one?
part, I can understand it for case X because we think no. Even for case X, I think that it's must.
Diana, I think initial conditions is starting from here. I guess. Why?
Because it's correct for Euro area. It started or no?
No,
it's the same. Yeah. Okay.
I think it's starting from here. Maybe I
There is
did
some historical part. Yeah. Okay. History, and after that, it's maybe Q1.
It should start from here. 1.5, 2.2. Let's check initial conditions.
If you mean that this is an actual data, why it's going to 1.5 and after the shock is going higher. Okay, let's check. Or
Yeah, that's a good question. Let's check the initial conditions for inflation. Yeah, initial condition 1.5 fourth quarter and 2.5 quarter before.
so we put it
1.5. It's starting from 1.5. Maybe. Yeah.
Okay, it's not actual data. We just put it manually and we can change it. And after that, we have shock.
It's the best estimate for fourth quarter because we did now for the fourth quarter we have actual data, but going back to late November, early December, that 1.5 was some estimate, I guess, from Philadelphia Fed or.
I guess it's too low, but okay, I got it. Thank you, Hakan.
Yeah, it's starting from here. There are some again. I don't know all these technical reporting things in dynamic relates. It's starting for inflation. It plots from the last two, from the first and first initial condition and from the previous period, but for interest rate, it's starting from the initial condition. Yeah, I think we need to work more to make this reporting better. Yeah, but that's
also the calibration part, as I can see, very interesting here because the Fed's reaction is more obvious here that they run much higher with their policy rates, but the persistence for policy rates for Euro area is, I guess, higher. Yeah, and also their inflation is not jumping as much as for US case. So calibration, I guess it's also the nice part to understand here.
Yeah.
Because you can see that for euro area, we can see the jump for policy rates. They just keep the tighter for longer, policy rates.
But here in euro area, they don't face any. So the story here in case X is the following: that so we have market, we have case A and case B, right?
Okay.
Then we have case X, and the assumption of the case X is that Fed is following the market reference scenario, and then in 2 quarters it recognizes that that the
They were false,
risk
yeah.
over case A scenarios is realizing. But exactly here in case X, we have demand size of the stocks the same as in case A. But here you can see that in case X, if it doesn't react in a time and follows some other scenarios and can see, for example, that risks of case A are realizing, in the future it should react much more aggressively and keep the interest rate higher for a prolonged time compared to case X. It's just a delayed response.
Okay.
And which is so all the credibility matters here, and all this non-linearity, because in linear case and in a perfect credibility case, what will happen is that Fed can, even if it reacts later and postpones this reaction, it can stabilize the economy with less costs in a linear
So
frame.
we switch to high inflation probabilities, and it's effect on our credibility stock. So my question here, maybe it's very stupid and I missed some parts. So this is the reaction of euro area inflation when we have shock in US inflation, yeah? This is not as simultaneously shocks in both US and EU coming from different type of shocks. So this is the euro area shock to US jump in inflation. Am I right?
In case X?
No,
So,
in the whole model.
no,
We have
then
simultaneous shock.
we have some shocks for euro area as well. For example, we constructed both case A and case B, both for euro and US. You can see here the positive demand shock for US and the positive demand shock for euro area. So which makes the euro area inflation much more persistent, okay?
Yeah,
They
but
have
the
that.
kinds of shocks are okay.
But what is different is in case X. In case X, what's happening here is that US is lower.
I understood that part, but I didn't understand the EU's case X.
Euro area's case X. You don't
Yeah, because they keep the just policy rate just a little bit longer for the same rates, and after they started to go to their I don't know, equilibrium steady state level.
Yeah, let's.
Why they don't rise their policy rates like in US?
Because Diana, because they followed the rule.
Because they followed Taylor
Their reaction function.
reaction
They
function,
just follow the
not loss
rule.
function.
But
Oh,
what
okay.
happens is that US doesn't following the rule. It follows the market reference. Then it recognizes that case A types of risks are realizing. And it
So
should
for
react.
US, it's loss function with not asymmetric loss function. Yeah,
It's an
and
asymmetric loss function.
it's asymmetric for US, and it's inflation expectation reaction function for euro area case, which means they keep their Taylor rule like reaction function for monetary policy rates. Okay, I see. Thank you. Hi, Kajan.
Thanks for interesting questions.
No, I guess. Okay, thank you. Yeah.
Thanks, Diana. Any other comments, suggestions, or whatever? Or if you have some problems in installing, we can look. You can share them. We can look.
So maybe tomorrow we can ask our IT guys.
Yeah, tomorrow
Yeah.
we will start again at 10, and it will be better within diligent to to meet offline. Of course, we will have Zoom, but offline will be better. We can use some room and yeah, start tomorrow at 10. We will start from simple, I think from simple model, and then enrich it and go up to GINF. Any other questions? Lucas, you have you want something to say, or?
No, just I installed Daniel Julian. I guess I will have no problem to do that.
You have the same problem, you said?
No, I don't have the same problem. Just I need the code from email because the Zoom code doesn't get. But I'll get it from Annie or Sophie.
Yeah, I asked Annie to send you because your
Okay.
email. I don't have your email, so.
Sure. Thank you.
Yeah, and then we can test. Okay. Anything else?
Okay, thank you. Hi, Kajan. Not yet.
Okay, then
Thank you.
we will meet tomorrow again at 10. Thank you.
Okay, see. Thank you.
See you.
Thank you very much. Goodbye. Have a nice day.
Bye. Have a nice day.
Have a nice